Let's find potential energy of gravity field. So we can say that we have this situation. So there is a ground and there is a particle of mass m. It's in gravity field, and for our purpose we can define orientation of coordinate system in this way. So it means upwards. So j vector, base vector of this axis, heads upwards too. And naturally in gravity field the gravity force acts on a particle, and this gravity force from state 1 in motion from state 1 to state 2 makes some work. So particle is moving from state 1 to state 2. The definition of gravity field is like this. So x component is 0 as well as z component, but y component is this, minus mg. The size is mg and the orientation is against positively oriented y-axis, so therefore minus mg by j. And the derivative differential of displacement vector is dx, dy, dz. So we can follow the definitions if we want to find a formulation of potential energy of gravity field. So we can say that work of force is from R1 to R2 FDR, what is in fact multiplication of these two vectors, and in fact it is zero minus mg 0 scalarly by dx dy dz if we multiply corresponding components. There remains an integral of minus mg dy from y1 to y2, from position 1 to position 2. So then we can put minus mg out of the brackets, and there remains dy. If we continue, so it is minus mg by y2 minus y1. So it is minus mg y2 minus mg y1. We know the definition that if this field has potential, so this must be u2 and this must be u1, so that it is u2 minus u1. And also we know that v2 potential energy at state 2 is minus u2, and potential energy at state 1 is minus u1. So it is in fact, but I don't know if it is necessary to say, it is minus v2 and this is minus v1 minus. So it is then minus v2 minus v1. But more important is a conclusion that v2 is minus mj y2 and v1 is mj y1. From this we can deduce general formulation of potential energy. V as a function y is mgy. So we got a general formulation of potential energy at any place, at any distance in this direction. So I think it is in correspondence with your previously got knowledge, for example from elementary school or secondary school. Okay, so this is general formulation of potential energy of gravity field, mg by distance in y axis.